Yeah, thank you very much for the introduction. And welcome to this talk on hybrid electric vehicle drivers interaction with eco-automation, which is mainly the work of Matthias Arendt, who can unfortunately not be here today, so I'm looking forward to present our joint research here today. Basically, I would say we are living in a world of climate change facing challenges to reduce transport emissions. So what can we as human factors researchers do for sustainable mobility? I would say we have an important role here because energy efficiency is always a product of technical potential and user behavior. So if engineering continuously improves the energy efficiency of, let's say, vehicles, our task is to help users realize this potential. So basically, we have to guide users towards energy-efficient driving. We have to increase awareness and understanding of energy efficiency, and we have to support users in their energy-related decision-making, for example, by designing optimal user interfaces. Now, one of the largest megatrends of our times in the vehicle sector, as we all know, is, of course, automation of more and more driving functions. Yet the strange thing is that so far almost nobody seems to connect these two megatrends of automation and energy efficiency, at least in the human factors literature. So just to give you one example, let's take a transportation research part F as a key journal in the field and make a very rough keyword search. Then you'll find 180 papers to date on automated driving, mostly from the last 5 years, but only 2 papers that also include the term energy efficiency somewhere in the paper. So there's a real need for empirical human factors research to increase understanding on drivers' interaction with eco-automation. And here it's interesting to note that automation for improved energy efficiency is becoming increasingly present and prevalent already today, so even before the widespread market introduction of self-driving cars. So what is exactly eco-automation? We suggest there's a working definition from a human factors perspective that eco-automation is any automated control system that manages the vehicle's energy dynamics based on or respecting the driver's discrete and continuous inputs, so control actions. So eco-automation is mainly or basically a functional module between driver inputs and the actuators in the vehicle that actually consume energy. So like the actuation of an electric motor or a combustion engine. Now, as you can imagine, such an eco-automation can take many forms. So it could be, for example, part of an adaptive eco-cruise control, or could be implemented as driving modes that change the drivetrain response characteristics, or it could be on your driver style selection menu on your level 4 automated vehicle. So on the one side, such inputs to the eco-automation can be discrete, like selection in a menu. On the other side, they can be continuous, like drive pedal inputs. Yet in any case, the energy automation does the same thing. It tries to mediate between this human driver and the energy efficient operation of the vehicle. So it tries to find an optimum between driver's wishes or goals and the vehicle energy efficiency. And the interesting thing is that it has to infer the driver's wish from the driver input. So based on what it offers the driver to communicate his driver wish, so the interface, it has more or less possibilities to really adjust to the real wishes of drivers. Now, a particularly interesting case to study user interaction with eco-automation are hybrid electric vehicles. That is because hybrid electric vehicles combine an electric and a combustion motor at a very highly dynamic fashion, as you can see here in the video. So optimal eco-driving is quite challenging for drivers of such vehicles, so really optimal eco-driving, because of these complexities of the energy flows. Because of this, HEVs are typically equipped with an advanced eco-automation that dynamically controls these vehicle energy flows based on the driver's inputs. However, as you can imagine, this eco-automation can only readjust somehow what the driver presets with his or her input behaviors. So to achieve maximum energy efficiency, the drivers must optimally interact with the eco-automation, or the driver behavior must somehow align with the eco-automation. And this interplay is somehow reflected also in the large variance you find between drivers of such hybrid electric vehicles. So what you can see here, so large variance in fuel efficiency, of course. So what you can see here is an analysis that we conducted on more than 1,000 HEV cars in the Sprit Monitor database. So it's a database in Germany. We can log your fuel consumption, and you can see other people who log their fuel consumption. And you can see here that there's quite a substantial variance between drivers. So key question is, what constitutes and determines, in the end, optimal driver-automation interaction? And as a first step, it is particularly interesting to study this question for the case of drivers who have at least a basic interest in energy efficiency, because their active eco-driving efforts may either align very well with the eco-automation or may even interfere with the eco-automation, so based on how they intervene into the eco-automation. Interestingly, we already found a very first preliminary indication on this topic in our initial interview study on the topic, where we interviewed HEV drivers on their eco-driving strategies and found without explicitly looking for it, that drivers seem to somehow adapt their driving inputs to participate in the automated control of energy flows. So just 3 illustrative quotes. So while some drivers seem to tend to passively observe the eco-automation, as you can see here in the middle, other drivers rather try to actively integrate their behavior with the eco-automation by adapting their drive pedal inputs, so continuous inputs. And other drivers also use the discrete driving modes, I'll talk about this in a second, to intervene into the eco-automation, so here on the right side. So as a very first step into this topic, we decided to study the much more simpler case of drivers' manual interventions into the eco-automation via using these 3 driving modes that were available in the HEV model that we chose for the study. So basically in this Toyota Prius model, drivers have 3 modes. First, the E mode, which, in the end, switches the gasoline engine off and forces the vehicle to drive electric as long as possible until the battery is empty. Second, activating the B mode, which somehow intensifies the deceleration once drivers take the foot off the pedal, so gas pedal. And the N mode, which deactivates retronative braking when the driver takes the foot off the gas pedal. And in our interview study, we already found, interestingly, that several drivers actively use the E mode, so the EV button, to somehow increase energy efficiency, which is actually not a good idea. And second, there are several drivers who rather tend to mistake the B mode to be a very effective or optimal retronative braking mode, while it indeed, the intensified braking rather comes from engine braking. And only some drivers understand that gliding in neutral mode is better than just grabbing any chance to do regenerative braking. So our research questions for this more quantitative analysis were, how do drivers interact with the eco-automation in terms of the usage of these 3 driving modes, so these manual interventions? How does this usage of the driving modes relates to fuel efficiency, and how do trust in the eco-automation and technical knowledge relate to the usage of the 3 driving modes? To address these questions, we conducted an online survey with 121 HEV drivers who regularly logged their fuel efficiency. This was important. You will see why in a second. And the survey also included other topics, including all dealing with the everyday interaction with energy resources in the HEV. And we used the structural equation and modeling approach to analyze the relationships between the variables, because this had several advantages for us with regard to alpha error and measurement models. So here's how we assess the variables. First, we assess the usage of the 3 driving modes with single item indicators you will see on the next slide. Second, we assessed fuel efficiency with a procedure that we have developed and validated in earlier research, because the challenge, of course, is here that fuel efficiency not only varies because of the driver, but it, of course, also varies due to temperature, terrain, city versus rural driving, vehicle model, and so on. So in our procedure, we ask drivers to estimate the average consumption for 2 standardized scenarios. And this is, of course, only possible because they regularly log their fuel consumption actively, so they are quite knowledgeable on their fuel consumption variations. And finally, we have to correct for the vehicle model. So we had 3 sub-models of the Toyota Prius in our study, and we used Sprit monitor data, so data on all the available HEVs to do a standardization. And finally, we also did a cross-check here. So we also asked drivers to give us their last 6-month average fuel consumption, and afterwards we asked them to provide us their actual logs and compared these 2 estimates and found quite a high correlation here. Okay, third, we assessed trust with the Giant scale with an adapted instruction, and we assessed finally knowledge with items that we had used in previous research. Okay, so results. First, you can see here the usage of the 3 driving modes that drivers use to intervene into the eco-automation. And you can see here that the usage frequency is highly diverse. So if questions arise, items were deduced from interview statements that HEV drivers made in the previous interview study. So these here are liquor type scales. So 1 is fully disagree, 6 is fully agree. So you can see that quite a few people used the E mode, at least to some extent. This tendency was less pronounced for the B mode, so less people used this. And only a quarter of the participants used the N mode, at least somewhat. And now, of course, the interesting question is how is the relation to fuel efficiency? Indeed, the N mode, the usage of the N mode was related to higher fuel efficiency. So people who rather used this way of intervening into the eco-automation achieved, in the end, a higher fuel efficiency, so consumed less. It was the other way around for the B mode, so negatively related to fuel efficiency. Yet, surprisingly, there was no relation between using the E mode and fuel efficiency, and we were really surprised by this. And maybe one possible explanation that we cannot rule out because we don't have such detailed data is that many users may only use this EV button in situations where it's not totally disadvantageous. For example, on parking lots, where it doesn't make a big difference. Okay, with regard to trust and knowledge, we found that indeed drivers who trust the eco-automation less try to manually intervene into the system by initiating electric driving with the EV button. Drivers who have more technical background knowledge are less likely to intervene by using the B mode. They either likely know that the B mode doesn't really do something good for regenerative braking, or they know that doing a lot of regenerative braking is not the way to go. So they less misinterpret the B mode. Okay, so what do we take from this talk? I think we made a small but first step into the examination of drivers' interaction with eco-automation, and we observed high user diversity and drivers' interaction with the eco-automation in terms of these 3 driving modes. So while half of the drivers used any of these modes, the other half did not. Further, drivers' usage was related to eco-driving success, so fuel efficiency, and trust and knowledge could at least somewhat explain a variance in the usage. So we think it's a promising field for further research, yet of course much more work needs to be done. This questionnaire approach was okay for what we did here, but as a next step we need field studies with logger data and a very precise observation, and maybe also interactive e-diary apps to study the drivers' subjective strategies more in depth. And we need to develop and test interfaces that actually try to optimize the integration of human users in eco-automation. If you want to know more, then you can check out our talk from Auto UI last week on the Energy Interface Challenge, which is on our YouTube channel, or check out the references or get in touch. Thank you.